All right, so today's video notes are all about elements and their structure. We're kind of starting off this first official unit looking at the smallest particles and how they're structured, and then we'll kind of grow from there. So basically everything in the universe is made of matter. And this is probably something you've talked about way back in 4th or 5th grade science. And that everything includes living things. So what is matter? Well, matter is made up of elements. And in fact, if you were to look at all of the elements that we've discovered so far in the world, it would make up the periodic table. So everything that is on the planet, living and non-living, are made up of a variation of these elements. These are all elements. And these are things you've heard of before. An element like oxygen, the element hydrogen. Those are things you've heard of before. So when we talk about life science, things in biology, we really look at basically 4 main elements, because 90% of all living things are made of oxygen, carbon, hydrogen, and nitrogen. Now there's a ton of other little elements that play a role that we'll be talking about later on, but these are the main elements. And if you were to take a look at them on the periodic table, you'd see that they're all very close together. All right, so if we were able to take a look at an element and look at what its structure is, this is where the atom comes in. The atom is the structure of an element. It's the simplest particle of an element that retains all of the properties of that element. Now, you don't necessarily need to draw this picture right now because we'll be drawing some other pictures. So for me right now, I would write the definition down. Notice it's in red, so that might be a new vocabulary word for you, so you should be highlighting in red. But I wanted you to kind of see the basic structure of an atom and know that there are actually 3 different subatomic particles, and that's what we're going to be focusing on for the remainder of this lesson. There are a particle called a neutron. These are neutrally charged particles, which means they don't have a charge. Then there are protons, which are positively charged, and usually they're represented by a positive sign. That makes it easy. And then there are electrons, which are usually indicated by a negative sign because they have a negative charge. All right, so let's draw the basic atomic structure. Let's put those subatomic particles where they belong in an atom. So what I want you to do is go ahead and draw what I show you on the screen and label what I show you on the screen as well. Okay, first of all, an atom always has a nucleus. And so we'll just draw it as kind of a circle. Make sure you label that the nucleus. And in the nucleus, and around the nucleus are what we call energy levels. Okay, those energy levels circle around the nucleus. Now within the nucleus, the subatomic particles, the neutrons, are found in the nucleus. Remember, those have the neutral charge. That's why I have a 0 representing those, because they're not positive, they're not negative. But also in the nucleus are the protons, the positively charged particles. They get to hang out in the nucleus together. And then in the energy levels, those circling around the nucleus are the electrons. Remember, electrons are negatively charged particles. So that is the basic atomic structure. Now here's one thing to remember. In an atom, the number of electrons are equal to the number of protons. Now, I apologize, that's probably cut off a little bit at the bottom. So let me say it one more time. In an atom, the number of electrons are equal to the number of protons. So if I have 2 protons in the nucleus, I'll have 2 electrons circling around it. If I have 10 protons in the nucleus, I'm going to have 10 electrons circling around the outside. They're equal. Okay, let's move on. Here's just an illustration of the basic atomic structure. There's our nucleus with a positively charged proton. So we have 1 negatively charged proton circling around the nucleus. I wanted you to understand the concept of these electrons are actually moving around the nucleus. They are circulating. So if we go to a helium atom, they have 2 protons in the middle, which means they have 2 electrons. And then it goes on from there. If we have an atom with 6 protons, then we have 6 electrons. Now there are 6 neutrons as well, but remember they're neutrally charged, so we really don't talk about those so much. We're focused more on the protons and the electrons. All right, so now we're going to write down the steps for drawing an atom. We're going to write down the steps. I'm going to model that for you. We'll work through some together, and then you'll do a few for homework. Okay, so here's step number one. If I'm asking you to draw an atom, here's the first thing you need to do. You need to find the atomic number. So you're thinking, well, what's the atomic number have to do anything? This is a very important piece of information you always start with, and this requires us to take a look at your periodic table, which is why you were supposed to pick one up or get one before you left class on Friday. Here, if you take a look at what's on the screen here and take a look at your periodic table, you'll notice that the atomic number is the whole number listed underneath the symbol. That's the atomic number. Now, why is this important? Because the atomic number is equal to the number of protons. So we need to know how many protons are hanging out in that nucleus. So this is the number we need to get first. So let's practice this really quick. Take a look at your periodic table, and I want you to find sulfur. Sulfur's on the right-hand side of your periodic table. Take a look and find the atomic number. Hopefully you found it. It is 16. So that means there are 16 protons. The atomic number is equal to the number of protons. Let's try one more. Take a look for krypton. Krypton's also on the right-hand side of your periodic table. What's the atomic number? It's 36, which means the number of protons are 36. Okay, that was step one. We find the atomic number. Now we're going to draw the nucleus and write the number of protons inside the nucleus. This is just something that I would love you to get into the habit of doing because this really helps you be successful when drawing an atom. Always write the number of protons in the nucleus so you know how many protons are there. The next step is to draw the first energy level. That circle that goes around that nucleus, draw that one first. But here's the thing, only 2 electrons can be found on that first energy level. Only 2. So if you have more than 2 electrons to draw in, that means you need to draw another energy level. But each energy level after the first one holds up to 8 electrons. So first energy level is 2 electrons. Any other level after that is 8 electrons. So let me model this first one for you. So you might want to draw this one in your notebook just so that you are seeing what I'm doing along with you. All right, so take a look at hydrogen, find it on your periodic table, and you want to find step number 1, the atomic number. I see that the atomic number is 1. So step number 1 is to draw the nucleus, and I'm going to write 1 proton, and I put a positive next to it so I remember positive protons are in the nucleus. Step number 3 is to draw the first energy level. Now remember, protons and electrons must equal each other. So if I have 1 proton, that means I only have 1 electron, and I'm just going to draw in a dot to represent that electron. All right, it's really that simple. So let's look at boron really quick. Look it up on your periodic table. The symbol is B, and it has an atomic number of 5. Hopefully you found that. So let's follow our steps. First, we draw the nucleus, and I always put 5 in there. There's 5 positive protons, which means there must be 5 electrons circling around that nucleus. So we do the first energy level. But remember, the first one can only hold 2 electrons. But I need 3 more because I need 5 electrons circling around my 5 protons. So that means I need to draw the next energy level, and I'm going to put 1, 2, and 3. Now this is kind of a good habit to kind of pair them up as you go along. So try to follow how I'm modeling to draw these electrons. It really does help you keep track of what you're doing. All right, now that you've had that practice, let's move on. You already did this. All right, so let's take a look at this atomic structure. Now you don't need to draw this one in your notebook, just watch. If there are 10 protons in the nucleus how many electrons need to be circulating around this nucleus? Hopefully you answered 10, right? 10 protons and 10 electrons. So to draw this, we're going to put 2 electrons on the first energy level because that's all it can hold. And then you're going to put the remainder of the electrons around the outside. And notice how I kind of pair them up as you go along. So if I count electrons, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 protons in the nucleus, 10 electrons around the outside. All right, so let's practice 3 more, and then I think you'll be ready for the homework. So let's take a look at helium. So take a look at your periodic table. Step number 1 is to find the atomic number. I see that the atomic number is 2. So draw these along with me in your notebook. We're not going to do oxygen yet. Let's do helium first. All right, so here is the nucleus. 2 protons are in the nucleus. Then we draw our energy levels. So how many electrons do we need? Well, we need 1, 2. And we're done. So let's take a look at oxygen. Look it up on your periodic table. It has 8 protons. The atomic number is 8. So let's draw it. 8 protons. And then we draw energy levels. So here's 2 electrons. And then we need 3, 4, 5, 6, 7, and 8. And you can always go back and double check. Do your protons equal your electrons? 8 protons, 8 electrons. I'm good. All right, let's do the last one, magnesium. Look it up. It has 12 protons. So let's draw that. Nucleus with 12 protons. And let's draw the energy levels. First energy level only holds 2. But we have 12 more to go. Or 10 more to go. Sorry, I know my math. So let's do the next energy level. Count them out. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 2 more. So we do the next energy level and add 2 more. 12 protons, 12 electrons. Okay, guys, that is it. Don't forget, 3 questions with some green, and now I know in blue. And here's your left-hand side. Underneath your periodic table, pick any 3 elements and draw their atomic structure. Just tell me what they are and what the atomic number is, and then draw it. And use some color. Your drawing is already a drawing, so you don't need to add an additional drawing, but any 3 elements you choose. All right, I will be stamping this on Monday. Hopefully you got it done.